Okay, good. Excellent. Well, let's go and get started. This is me, Erik Gross. I will be your instructor for the class. I've been a nerd my whole life. Been programming computers since I was 11 years old. It's been a while, right? I spent some years in the Navy as a nuclear reactor operator and electronics technician. And that's actually where I found out that I really love to teach. I didn't know that. I got volunteered to teach. I was super scared the first day, and it turns out that I love it. I got more and more into it over the years. I'm also the co-founder of the Tech Academy, the school that puts on these free classes. More about that to come. But anyway, I'm glad to be here, and hopefully you'll get a lot out of tonight's class. A couple basic guidelines for the class. We have an assistant who you will notice inside of chat, and she helps take care of answering, monitoring questions, housekeeping stuff behind the scenes. If you need anything at all, she'll be watching the chat. Okay. Make sure you're nice, or she'll boot you. Although I think it's been over a year since we had anybody be obnoxious in these classes, which is wonderful. I want to stress that these are introductory coding classes, but they'll still be challenging. You might run into challenges as part of the learning process, and that's to be expected and welcomed. Part of that learning process is working through those challenges. Please do use chat as needed. I try to monitor it during the entire workshop. One specific note on that: write the code exactly as written. And this is because a misspelled word or a missing symbol or even something capitalized that shouldn't be capitalized can result in errors in your computer program. And we'll cover a little bit about why that is. And a couple other things. If you fall behind, like in a moment here, we're going to be writing code. Okay. And I try to go at a fairly decent, like moderate pace for people. But if you end up falling behind, don't worry about it. Just stick around and listen, because you'll still learn a lot, even if you're not able to type out every bit of the code that we cover. We also very often get asked about whether these are recorded. They are, and we put them up on YouTube, usually within about a day. We'll get you links to all of our YouTube channels and all of our other stuff at the end, okay? You're also going to get the full code to the Snake program that we'll be looking at. And you'll be able to play the game and even modify the program if you want to. And like I said, we'll give you a bunch of links to everything about us. So we've already, used the chat. I don't have any doubts that people, know how to use the chat. So we can just go right through that. If you didn't get a chance to let me know where you're joining us from, please drop into chat and let me know. I love hearing from people all over the country and the world. I am in Slidell, Louisiana. That's about 30 minutes east of New Orleans. And we were, of course, last weekend, the world headquarters for the Taylor Swift fans around the globe, and it was fantastic. I didn't get to go to the Eras tour because I didn't have a spare $1,200 lying around to buy tickets, but I sure as heck wish I did. Anyway, yeah, drop in and say, oh yeah, Detroit, Michigan, Jackson, that's Michigan as well. 45 minutes south of Lansing. Got people here from England, Toronto. This is fantastic. We truly have an international contingent in the class today, which I love. All right, so let's move into this. The basic agenda is we'll have a short explanation of the Tech Academy, who we are, what we do. And then we're going to write code. You're going to get your hands dirty, actually writing some code. Quick check. Let me know in chat. Have you ever written a computer program before? Yes or no? Drop it in the chat. Have you ever written a computer program ever in your life? Bunch of yeses. I'm watching chat. Drop it in the chat. Have you ever written a computer program? Good. A bunch of yeses and just started learning. Jim, are you serious? Jim mentioned a computer programming language that I learned in 1997. That's fantastic, man. Yeah, I share that experience with you. That's wonderful. A couple no's. All right, good. Well, I want to stress two things, particularly since we have a large percentage of the class that has at least written a computer program. One of the things that we're going to cover in the class tonight besides the fundamentals of JavaScript, is what are the core elements of any computer program? No matter what language you're writing it in, no matter what the program does, there are, as we're going to cover, 5 fundamental elements to any computer program. And the reason I bring it up is because we found this to be one of the most successful approaches in trying to learn programming in general and trying to learn a specific language. And so if you can get like those 5 core elements of a computer program, if you have them nailed down, your journey in breaking into technology is going to go a whole lot better. So you have that to look forward to in a little bit here. So when we're done writing code, we'll have a brief Q&A session, although I do try to watch the chat. Speaking of the chat, Dana asks, will the recording on YouTube be there permanently? Absolutely. You can go back and find YouTube recordings from 12 years ago from our school. If it goes out on YouTube, it's there, including all those embarrassing videos from me 10 or 12 years ago when we started the school. And we had the world's worst video camera and horrible audio, and I was about 30 pounds heavier. So yes, they're all out there on YouTube. Isn't that great? You know, but all joking aside, yes, all of our videos go up there and they're there permanently. Okay, and we'll get you links to all of that at the end of the class. When we're done doing the coding, we'll cover some information specifically about our boot camps, how they work, what they're all about, right? And there's a free gift for you at the end, so please stick around till then. The whole class should take about an hour to an hour and a half. All right, so quick word about the Tech Academy. We provide boot camps. Boot camps, if you're not familiar with them, are intensive technology certification programs. They're designed to prepare people for entry-level positions in tech. You can almost think of a boot camp as a trade school for the computer industry, which is pretty cool, right? Boot camps typically last 3 to 6 months. They focus on practical, modern skills, the skills that people are hiring for today. At the Tech Academy, we've been offering thorough, budget-friendly, flexible, trusted coding boot camps for well over a decade now. We were around at the beginning of this industry, and we love it. We love helping people break into tech. Our programs are cost-effective, they're self-paced, they're fully online, and this is important, they're tailored for beginners, people that have no prior technical or coding knowledge. That's who our programs were built for. If you've already got some experience, that's great, but you don't need it, which is pretty cool. And of course, we teach in-demand skills. Our classes are, endorsed by stellar online reviews. They're flexible. They're designed to fit around your personal schedule. And we prepare you for a technology career by giving you a very well-rounded toolkit. And you can learn more about that later on, right? In America, the average price of a boot camp is around $13,000, $14,000. Ours are under the national average. In fact, we have boot camps that start as low as $59.80. And the last thing I want to tell you about is just our mission statement. Like, why do we even exist? And it speaks to why do we even do these free coding classes. Our mission statement at the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. That's what we're here for. Our product is you working in tech. All right, so let's go into a couple basic definitions. One is just a program. What's a program? Well, a program is just written instructions you can put into a computer that will make it do stuff. That's what a program is. But the important thing is you are making the computer do something. Instead of having to use a computer or a specific program on a computer the way someone else decided it was going to work, you get to decide how that program is going to work, which is pretty cool. You do this using a programming language. It's just an organized system of words and symbols and phrases that give you the tools to enter those instructions into the computer. So programming languages are what we use to make programs. And finally, there's the word coding. That's just the action of entering those instructions into the computer. We call that coding, right? And the instructions you enter, we call those instructions code. So there you go, some basic definitions. Now, let's talk about JavaScript. We're actually going to talk about 3 things related to JavaScript. So there's JavaScript itself. It's a really, really popular programming language. Been around now for almost 30 years, right? And originally it was designed to add dynamic functionality to a website. I don't know if you know this, but way back in the day, in 93, 94, 95, web pages were fixed. Like, you couldn't change them easily at all. There was nothing like you'd roll over a calendar and it would expand, or you would be able to, enter in form data and apply for something, or there's no, e-commerce going on. There was nothing like that. And so we needed a programming language to help programmers do that for the web. That's what JavaScript is. Since then, it's grown, and you can use JavaScript to do a whole lot of things, okay? So that's JavaScript. The next technology you need to know about when you're talking about the web is HTML. Now, HTML stands for Hypertext Markup Language. It's not a programming language. In a little while, you're going to see, as I mentioned before, these 5 fundamental elements of any computer program. And hypertext markup language doesn't do any of them. So what is it, and why do we care about it? Well, it is a language, but it's not a programming language. It's a language that lets you tell a computer how to modify the appearance and the content on a web page. And that's pretty cool. Every web page you're looking at, including, quite frankly, this slide, because it is on a web page owned by the company Zoom. This slide you're looking at right now is actually made with HTML. And to get even nerdier and more precise, I created this slide at Google, in my Google Drive account, using Google Presentations, which many of you are familiar with. That site uses HTML. And so all the content you're looking at ultimately right now is made with HTML, except for my face. My face isn't made with HTML. Good. So let's look at the third technology of the web. It's called CSS. Now, this stands for cascading style sheets, but let's start with just the last 2 words, style sheet. All a style sheet is some instructions that can control the appearance and style of all the content on a page. So, for example, let's say you want every image, every picture on a page to have a border or not have a border. You can control that with a style sheet. Let's say you want to have the font of a web page be one font, except the very first letter of a paragraph, you want it to be a different font and much larger. You can control that kind of thing with this thing called a style sheet. Well, cascading style sheet just means you can write those instructions in one place, and they ripple out and they apply to every single web page in your entire website. It's really powerful. So here you see these 3 things. We call these the holy trinity of the web development world. With these 3 tools, you do most web development tasks. Now, we're only really talking about JavaScript tonight, but the point is that when we start actually writing code, you're going to see JavaScript for sure. We're going to write some JavaScript code, but you're also going to see some HTML, and you're going to see some CSS. And I want you to be able to, at least when you see them on the screen, know what they are. But we're going to be working in JavaScript, okay? So here it comes, these 5 elements of a computer program. And yeah, I can be kind of dramatic. I kind of like computers and I get excited. But I'm not kidding you. These 5 things are some of the most important data you will ever learn about computers and computer programming. There really are only 5 things that are ever found in any computer program, from the tiniest little small computer program to big giant programs with thousands of different files in them. There's only these 5 things. So what are they? Well, you can see the first one. It's called an entrance, or the first instruction. Now, this one, it just means what it says. Excuse me. There is a first instruction to any program. When you go onto your computer and you find a little icon for a program, say Microsoft Word or a video game or whatever, and you double click on that thing and the program starts. We've all done that thousands of times, right? When you do that, there's going to be a very first instruction when you start the program. Why do we care? Why is this a basic element of the computer program? Well, There's two things to think about here. First of all, the program you're running is on a computer. Like right now, I'm running probably 20 or 30 programs on my computer, right? Well, every single one of those programs works with data. And that data has to be stored somewhere in the computer. Where does it get stored? Well, it gets stored in these little devices right inside this box next to me. My computer's on the desk next to me. Right inside this box are what we call memory storage devices. They're actually just little teeny electronic pieces around 3 or 4 inches long, and they plug inside your computer. But on those little devices are little teeny electronics that can store information. Truthfully, on a lot of these memory storage devices, there's between 4 and 8 billion locations where you can store data. Computers can work with a lot of data, but we don't really care about the fact that there's a lot of it. What we do care about, in fact, is the fact that you've got to store that data somewhere. And that's what those memory storage devices are for, right? Now, again, why do we care about that in relationship to the very first instruction of a computer program? Well, it's this. The data that your computer program is going to work with is super important. And the last thing you want is to be storing some data inside one of those memory storage devices in your computer. And then you start up some other program on your computer, and that program goes in to the area where you're storing data for the first one and changes it. You're toast. You have a big problem at that point. And so what a computer does is this. The moment you start a computer program and that first instruction begins, the computer goes into the memory storage device and blocks off a certain section of those available places to store data. A certain number of those locations are reserved, and they're only to be used by your program. That's the only way you can really manage this process inside a computer. And so that first instruction is important for that first reason. It tells the computer to reserve some of that memory. Here's the second reason that it's important, and it's something that matters to you and to me as technology workers. And here's what it is. Knowing that every program is absolutely going to have a first instruction is one of the more useful things to have in your arsenal when you are assigned to work on a program for the first time. And this happens all the time. You work really hard. You either go to college or a boot camp, or you self-study and you get that first tech job. And after you're overjoyed because it's pretty awesome, you get assigned to be on a team, and that team could be responsible for a number of computer programs. And usually those programs have been around a while and they can get pretty complex. So where does this entrance point come in and become valuable to us as technology workers? Well, it's this precisely. When you have to start to understand an existing program, the best place you can start to truly understand it is right at the beginning. And so knowing how to find that first instruction, the various types of programs you're going to encounter, is one of the more valuable things you can do or learn about as a technologist, as a computer programmer. Because the moment you find that first instruction that gets performed, then you can follow along to the second and the third and the fourth and so all the way along after that. And that just gives you the most logical way to start to understand what that computer program is all about. Yes, there might be documentation about the program. But for you wanting to know the code, the actual instructions that were put in, that's how you start. You find where's the first instruction and you say, what exactly does that do? Okay, good, I understand that. What is the next one? And usually after 5 or 6 or 7 instructions in, you're starting to really be more calm. And go, oh, yes, this might be a very large program. There's a lot of complexity here. There's thousands of files. There's a whole lot going on. But what you know is you're starting right at the beginning, and there's nothing to stop you from just tracing through one instruction at a time and eventually understanding the whole thing. I'm telling you, it's a very, very stabilizing thing as a developer, as a technologist. So this is the entrance point, and I went on about it a bit because it's one of the things that's helped me tremendously as I've moved from position to position, or had to, quickly get up to speed on a brand new program that I've never worked on before. All right, let's move on to the element number 2. One of the important elements of any computer program is what we call a variable. This is a way it's something you can build into a computer program that lets the program, and this is important, it lets the program keep track of information that could change as the computer program does its work. I think you can probably picture how not valuable a computer program would be if it couldn't keep track of data that would change. You have a program that helps you run a school, and you can't add a new student, or you can't change someone's grades. You see how it just would not be a valuable program. So this is why it's considered one of the 5 fundamental elements of a computer program is a variable. How do we keep track of data that could change? The next element of a computer program to look at is what's called control and branching instructions. These are instructions you put in your program that force your program to make a decision. And these are amongst the most powerful things you can learn about in any new programming language. How do we do this? How do we give our computer program some data and tell the computer program to make a decision about what to do based on what that data is? It's super vital. Essentially, what you're doing is you're saying, I have an instruction that can control which way the program goes, and I have 2 or more available things that could happen after that. We call those available things branches. And you're going to build these tonight in code. The 4th fundamental element of any computer program is called a subprogram. It's one of my favorite things in the whole computer programming world. This means exactly what it says there, programs within programs, but we'll be a little more precise. A subprogram is a set of instructions, a set of computer code that you can call on anytime you need the exact instructions to occur. Now, why is that valuable? Well, let's picture what it's like if you didn't have a thing like this. And this is the way it was in the 1950s, 60s, and 70s, when a lot of the formative work was being done on computer programming. Here's what it would look like if you're writing a program. Let's say you had a program that was, 4,000 or 5,000 lines long, and this is not unusual. There are programs with 10,000 instructions, right? And you're the programmer, and you're trying to write all this down and then enter it into a computer. Well, here's what was happening over and over again. Programmers were noticing that in any program, they would find themselves repeating exactly identical instructions over and over again at various points in that large program. There might, for example, be 5 instructions that were always done exactly the same, in the exact same order, many different places in that computer program. Now, this is a problem for a few different reasons, but I'm going to talk about 2 of them. One of the biggest problems with this is that it's so easy to make a mistake. You've got 5 things that are supposed to be identical, but you're doing it over and over and over again in your program. It might be really easy to just forget. Oh man, I forgot that 4th one. And now I've got to track down where I made that mistake. But the other thing that's really dangerous about that is, let's say you've got these 5 instructions that you're going to repeat many times throughout the course of your program doing its job. But then a little while later, you're thinking to yourself, I'm not quite happy with those 5 instructions. I need to change the middle one. There's something wrong with it. Or it could be made better in some way. What do you have to do now? You have to go back through that giant program and find every place that you repeated those 5 identical instructions and change that 3rd one in Every single location. And God forbid you miss one. And then some weird behavior happens in your program. It's not very workable. It makes our jobs very hard. And for those reasons and a few more, computer programmers decades ago came up with this idea of, well, why don't we make a thing, we'll call it a subprogram or a mini program. I don't know what we're going to call it, but I'll tell you what it should look like. I should be able to take those 5 instructions that I'm going to repeat over and over again and almost put them off to the side in a box and put a name on that box, put a name on that subprogram. And then when I am writing my big, long program, every time I need those 5 instructions to happen, all I have to do is write one instruction. And that instruction is go do the subprogram. And that's all you have to write. Now, that takes away a lot of the chances for error, but it also means that if you need to change, like in my silly example a moment ago, if you need to change that 3rd instruction in the subprogram, you only have to change it in one place. And now that change is reflected throughout your entire program. It's a very, very powerful thing to do. And you're going to build a subprogram tonight. You'll see how this all plays out. And finally, the last fundamental element of any computer program is an exit point. There needs to be a final instruction. Now, why do we care? The computer program is done. It's over, right? Well, we might not care, but the computer does. The computer that the program was running on does care. Why? Well, it has to do, again, with those memory storage devices. Remember that at the beginning, when we started our program, the computer said, oh, okay, hold on. I'm going to reserve some of that memory storage device space for you, some of those locations. Well, now that your computer program is exited, now that it's over, those memory locations can be released and made available to other programs. So these 5 fundamental elements, these are the core of any computer program. Other than number 1 and number 5, these are not listed in a particular order. Variables and control and branching instructions and subprograms can be used in any kind of order inside a computer program, depending upon what you need to happen. But I just want to stress again, these are the only things you will ever find in any computer program, period. All right, let's move on because I want to write some code. And you're going to build these things on the screen in code. So first thing we need is a code editor, which is just a workspace to write in your instructions in whatever programming language you're using and to run the program that you're creating. That's what a code editor is for. Now, we have a code editor. If I could have my assistant, yeah, there it is, right in chat. You'll see a link to the code editor. This one is online. Click on that link. And you should see something that looks like this, the one on the right. Well, they're identical, okay? And what you're looking at is a code editor. Now we're going to get into how to use it. But the first thing I need to do is have you set it up so you can see me writing code and you writing code side by side. If you have 2 monitors, that's nice and simple. Put me on the left monitor and put your code editor on the right-hand monitor and you're golden. But if you've only got one screen, then I need you to set it up so you have this Zoom window where you can see my slides over on the left. And then on the right, you have your this editor you just opened up. So basically, on the left, you'll have Zoom. On the right, you'll have your browser. Now, if you need a little bit of help doing that, sometimes Zoom isn't very cooperative in having you resize the window and move it around. And so you can click on the words Zoom meeting and then click restore. And that should reduce the size of the window for Zoom and help you can move it around, okay? There's a similar thing on your browser. If you look at the top right of your browser, usually, there's a little symbol that lets you resize it. And I want you to resize it and put it on the right-hand side. This is where the symbol is usually, is right here. All right, so I'm going to give people a second to get that arranged while I take a sip of water. I'm going to write some code. All right. Here's my code editor. All right. Now, let me explain what we're looking at. On the left over here is some code. Okay, I've highlighted some of it. On the right is an output window. Okay. So what we're going to do is we are going to write our code on the left and produce output on the right. And we're going to use very simple examples. We're not going to build out an entire computer game. That could take a long hours and hours and hours, and you'd probably fall asleep or want to kill me by the end of it. But what we are going to do is see how to build those 5 fundamental elements using JavaScript. And along the way, learn a lot of really important fundamentals about computer programming. Now, the first thing I'm going to do is show you the game that we're going to use as context. Okay. I think if I run this, I think I have to reduce the size. All right. I think it might be too big. There we go. Okay. All right, I'm going to go right. Hey, I did it. All right, so it's a snake game. Good. So we've all played Snake, I think, or something similar. Every time I eat one of the red dots, I get bigger. All right, so that's the snake game, okay? So we're not going to look into that in a bunch of detail. I just want to let you know that that's the game that we're going to use as our context for the lessons tonight. You are going to get all of this code, right? But I want to go back and just reinforce what we're looking at here. Now, let me make this a little bit bigger. Okay. So the first thing I want to show you about on the left-hand side is where the computer program isn't. This stuff right here is not a computer program. This is that HTML or hypertext markup language that I was talking about. All this stuff does is talk about the content that's going to go on the page. And this right here is not a computer program. This is just matching instructions for what's up above. And we're not going to get into that tonight. That's HTML and how do you make web pages. It's a subject for a different class. What we are going to look at is everything that's inside this script stuff. All of this. That is, in fact, a computer program. Pretty basic one. You can almost read it and figure out what we're doing. We're creating a variable called x with a value of 5. There's a variable called y with a value of 6. And there's a variable called z, which is x plus y, which means it's probably 11. And then we're doing something where we are grabbing something on the page called demo. Oh, that's up here. And we are putting our content into it because you can kind of see it right here. Now, we're not even going to break that down. We're going to build our own little program. So here's what I want you to do. I want you to erase everything inside these script tags. I'm going to leave it highlighted for a moment so you know exactly what to erase. And now I'm going to erase mine. So right here is where you're going to write computer programs, okay? We're writing actual JavaScript. Let's start by just getting something to pop up on the screen. Now, we have a really cool thing we can do where we can make an alert appear on a web page. We've all seen alerts before, okay? There's a built-in instruction in JavaScript called alert, and we're going to use it. So just type ALERT, and immediately after it, put an open parentheses and then a close parentheses. and then a semicolon. And I'm going to explain what all of these things are. Alert is a JavaScript instruction that says create a pop-up on a web page and put some content in it. The parentheses tell the computer what's inside here is the content that you will display in the pop-up. And then the semicolon says, this instruction is over. Go on to the next instruction. That's what these words and symbols mean. So the only thing we're missing is, what are we going to have appear in the pop-up? Let's go ahead and put in here some information. Let's do a double quote like that, and then go back inside the double quotes. Double quotes are how you tell the computer, hey, the data you're about to work with is text data. It's not a number. It's not a date. It's text information. That's what the double quotes tell the computer. So what do we want to put in there? Well, let's have fun and do hello, comma, world. That's pretty popular, been around for decades. There we go. I'm going to leave that for a moment. When you think you've got it right, hit run. And hey, there's our pop-up. It popped up and it said, hello, world. Now, we're going to have a series of pop-ups. So what I think I'm going to do to make this easy, go back in here and just do a 1 space. Just so that as you watch the pop-ups appear, as we write more and more code, it'll be super easy to keep track of which pop-up is happening. All right, good. So we have our first instruction. We covered some of the fundamental things here. I want to point out one of the biggest fundamentals. If you have an instruction that needs information in order to do its job, you give it the information by putting an open and closed parentheses right after the instruction, not a space and then the parentheses. Immediately after the instruction, you put the parentheses. That's how we call that passing information into the instruction. In this case, the instruction is alert. And we are passing in the text information, one hello world. You're going to see that pattern used other times in our work tonight. Run it again just to make sure it's still working. It says one hello world. Okay, good. Now, let's start using a variable. There is a built-in instruction in JavaScript called var. It stands for variable. This is how you create a variable. Now, this one you do put a space after. And what you're going to type next is, what's the name of the variable that I want? It needs an identifier. Like, what am I keeping track of? In this case, let's keep track of whether or not the snake has actually intercepted the food. Because remember, the red dot is the food, and when the snake eats the food, it gets bigger. So I want to call this variable intersect. And what I'm going to keep track of is whether or not the snake has intersected with the food. That's an important thing to keep track of. You're going to do that over and over and over and over and over again. Most of the time, it's not going to be true. But when it is true, now you need to make the snake longer. Okay, good. So we have a variable. We've given it a name. What we haven't done is given it any value, any data. Let me give you an analogy for this. In the computer, as we talked about before, are these memory storage devices. And we said that part of the job of the computer is when you start your program to reserve some of those memory locations. Well, we're about to use one of our reserved memory locations. And the way it works is like this. You can think of one of those locations as a bucket. And the bucket can hold some data. But you have to have a name on the outside of the bucket. You have to be able to identify one bucket from another. So you give them all names. What we have here is a bucket that on the outside of it, it says intersect. That's what it says, is intersect. What we're missing is there's nothing inside it. We haven't given it any data. The way you do that in JavaScript is you do an equals symbol like this, and then you put the data. In our case, it is a special type of data called false. Either true or false. And that's what we care about. We care about whether or not the snake has intersected with the food. So we're going to start with that not being true. We're going to start with that being false. Okay, good. That's pretty awesome. All right. So let's look at two different things here. Hit enter and let's do another alert. Alert, and in parentheses, you do your double quotes and say, has the snake intersected with the food, question mark, and then we're going to type false, and then do a semicolon. Now, run this program, and we get our first alert. That's the one right here. Hit OK, and we get our second one. Now, this is a problem because if suddenly it becomes true, well, we've already got, you can click OK again, we've already got an alert that pops up that is stuck on false. What we want to do is have this part of our message change based on whether or not we have had a snake intersect with the food. Well, watch how we do this. Go back here and erase false. Watch exactly where I put the cursor. Put it after the second double quote, but before the parentheses. In other words, we are still inside the parentheses. So we are still clarifying what is the information that we are going to give to the alert. What we want to do is we want to add on to what we've typed so far. We want to add on to this. And what we want to do is print the current value of our variable called intersect. And you do that by doing a plus symbol. In this case, plus does not mean math. What plus means in JavaScript, the way it's used right here, it means take two pieces of text, one on either side, and stick them together. The actual nerd word we use for that is called concatenate. That's what it means to take two pieces of text and stick them together. And what goes on the right-hand side of this? Well, our variable, intersect. Don't capitalize it. Of me, intersect. Now, this may or may not throw an error. If it does, I know how to fix it. Let's hit run. Ooh, look at that. That worked. You want to see how we can test that it worked? Hit OK. And now change your variable called intersect to true. Run it again. And notice the content changed. So we're now using a variable. We can change the value of this intersect variable whenever we want. Let's go down here to the bottom. And let's do, remember how I said I was going to number our alerts? Let's go back to this alert and do a 2 and then a space. I changed this right here. Just for those of you who are trying to keep track, okay? So now let's go down to the bottom here. And let's change intersect to have a different value. You do that by just saying the name of the variable, intersect, and using that equal symbol and give it a new value. In this case, we can go false. Now let's do another alert. Alert. And this is going to be alert number 3. Same content as before. Has the snake intersected with the food, question mark, space, and then you do your double quote. It's the same thing. Let's add on the variable intersect. Make sure you spell it exactly right. Has the snake intersected with the fool? Well, if I'm the fool, yes. All right. We'll run this. Well, there's our first pop-up. We know about that one. That's where we say, hey, just say one, hello world. Click it again. There's our second pop-up. Has the snake intersected with the food? Yes, it has. Why? Because immediately prior to this, we created a variable called intersect, and we gave it a value of true. So it puts that value right there. Click OK again, and now we get the third pop-up. Has the snake intersected with the food? False. All right. By the way, I'm watching chat. If you have questions at all, drop them into chat, okay? So we've done a couple things now. We can track which is the first instruction, and we can see it happen right here. We've made a variable, and we've used that variable, and we've shown that you can change the data in the variable and use it again, and we're now using the new updated data in the variable. That can be kind of valuable. All right, now, I don't know about you, but I don't want to particularly write this instruction here. No, I'm sorry. I don't know about you, but I want a way to tell my program what to do if there's been an intersection. Okay? So let's think about this. Every few milliseconds, we need our program to check, has the snake intercepted the food or intersected with the food? We need to do that over and over and over and over again. Now, if it has not intersected with the food, then we do one thing. We keep the snake the same size and keep it moving. If we do intersect with the food, then we increase the size of the snake and keep it moving. So we have two different choices here. Now it's time for that third element. When we talked about those 5 elements of a computer program, now it's time for how do you get the computer to make a decision? More precisely, for our little example we're going to do here, how do you get the computer to decide whether or not to make the snake bigger? Now, we all know, just because I demoed the game, that if the snake hits the food, then we make the snake bigger. But how do we put that in a computer program? You do it with the control and branching instructions that we talked about earlier. Now, in JavaScript, the most common control instruction, the instruction that tells the computer, make a decision. The most common instruction is called if. So go to the bottom there and type if. And then I want you to go very slowly here. Give me an open parentheses and a closed parentheses. And then give me an enter and give me a curly brace. You can find it above and to the left of the enter key. Hit enter twice, and then give me the matching curly brace. It's right next to the other one. I'm going to give you all a moment to finish writing this. Now, this control and branching instructions that I have here, it's not complete. I had you type it out this way so we can talk about the structure of how you would do this. How would you get a computer to make a decision? And it starts right inside these parentheses. So put your cursor right inside there. So to the left of this cursor, we have this word if. We have an instruction. It's a special instruction in JavaScript called a control instruction. We're telling the computer, I need you to make a decision. Let's be a little more precise, though. You're telling the computer, I'm giving you some data. You need to determine whether or not that data is true. If it is true, I'm going to give you one thing to do. If it's false, I'm going to give you another thing to do. And that's how the whole mechanism works. So what goes inside these parentheses where we have the cursor right now? The information that the computer has to figure out whether it's true or not. And you do that by doing a comparison. We're going to compare two pieces of data. Let's set that up. Hit space once. Hit equals twice. Then hit space. Now, we're still not complete here. We're building this from the inside out. This symbol, these two equal signs next to each other, that's one symbol in JavaScript. It's a very specific, precise symbol, and it tells the computer, please compare the two pieces of data on either side of this symbol and determine whether or not they are equal to each other. That's what this symbol means that I have highlighted. So we need information on both sides of it. The first thing we need to do is we need to put our variable intersect. Make sure you spell it exactly right. And on the other side, we need the built-in data from JavaScript called true. So look at this. We have given the if instruction, the control mechanism here, we've given it something it can figure out whether it's true or not. Is the value of the variable called intersect true or not? The computer can do that. Now we need to lay out, what do we do if it is true? Well, for our example, we're going to make that real simple. But the first thing to cover is that's what these curly braces are for. Inside the curly braces is where you put what to do if it's true. Now, just for readability, I want you to hit space a couple of times. It makes it easier to read your code. Doesn't change anything about what the computer does when it runs your program. It just makes it a bit easier to read. And all we're going to do to keep our example simple is we're going to do another alert. And we're going to say hit : snake gets bigger. Like that. Now, don't run your code. I would like you to guess in chat, what is our final alert going to say? Write your guesses in chat. When we run this code, what is our last alert that pops up going to say? All right, Ryan, we're going to talk about that guess in a moment. Anybody else have a guess? Oh, I should learn to type correctly. Snake gets bigger. There we go. Okay. Spencer got it exactly right. Now, Spencer's guess was number 3, has the snake intersected with the food? False. That's what's going to happen. Let's run it. There's number 1. There's number 2. There's number 3. Says, has a snake intersect with the food? False. And then that's it. Scott? Close. I left it off on purpose. So let's talk about this. Computers are stupid. Computers will, one, they'll only do exactly what you tell them to do. Number 2, if you don't tell them what to do precisely, they'll just stop. And number 3, they have literally no knowledge of any instruction after the instruction they are working on at that exact moment in time. We can read an entire page. Computers can't. The computer has no idea what comes next. So let's think like a computer. On the first instruction right here, it just does it. All right, I'm going to put an alert up that says, hello world. What's next? Oh, well, the next thing is I'm going to make a variable called intersect and give it a value of true. Okay, I did that. What's next? Oh, I'm going to make an alert happen. And it's going to say blah, 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 blah. And I'm going to add on to the end of it the value of the variable called intersect. And this is an important point. The computer has no idea that on the very next instruction, we're going to change the value of intersect. It can't read that. It doesn't know. And so when it performs this instruction right here, it can only use the current value of the variable called intersect. So then we do that. And then what do we do next? We now change the value of the variable called intersect and make it false. Then we do another alert. And this time, it does this text and the current value of the variable intersect, but we've changed it now. It is false. And now we do this funky thing. We say, well, if the value of intersect is equal to true, then do everything inside these curly brackets. But what is the value of the intersect variable? Well, we changed it to false right here, so it's still false. And so the computer says, well, this is not true. It's not true that the value of intersect is currently true. That's not true. And so it says, oh, well, I'm certainly not going to do what's inside these curly brackets right here. And it goes, well, what's the next instruction? And there isn't one, so it's just over. Program over. It doesn't do anything. Why? Because you didn't tell it to do anything. So now let's tell it what to do if this condition we asked it to check is false. What do we do if it's false? And you do that with another special built-in JavaScript instruction called else. So type that in, hit enter, and give me that same curly brace, a couple of lines, and another ending curly brace. And go back up, because right in here, in between these curly braces, here's where you're going to put the instructions that will be done if our condition is false. Again, hit space a couple times just for readability. And let's make an alert happen. This one will say, missed. Snake stays the same size. Like that. Now run your code, and we can watch our first alert. We know what that's going to do. Our second alert, our third one, and now we'll get a fourth one, and it says, missed. Snake stays the same size. Okay, good. I'm watching chat. Any questions so far? Okay, good. Now, I'm going to hit enter a few times at the bottom here, just to give ourselves some room to work in. Okay, so you can see what I'm doing here. Let's talk about an important concept. Remember watching the game, how the snake kept moving, right? Every single time the snake moves one more position, every time that happens, we need to check all over again in our program, did the snake intersect with the food? That means that hundreds or even thousands of times while someone is playing the game, we're going to have to figure out all over again, did the snake intersect the food? I don't know about you, but I don't want to have to write this code thousands of times in my program. This is where a subprogram comes in. What if I could just make a little subprogram, and every time the snake moves, we run the subprogram, and that subprogram checks whether or not we've intersected with the food. This is where subprograms come in so valuable. Let's make one. Go down to the bottom here, right after the final curly brace. In fact, go down one more just for some readability. Make it nice and easy to see what we're doing. In JavaScript, this whole concept of a subprogram is very much in use. But what we call them in JavaScript is functions. Every language calls them whatever it wants to call them. In some languages, a subprogram is called a function. In some, it's called a method. In some, it's actually called a subprogram. In some, it's called a subroutine. Regardless of the word, it's all the same concept. And before we write one, I want to stress one super important thing about creating one of these subprograms. Again, we call them functions in JavaScript. And here's this important thing about them. When you first describe one in the code, and we're about to create one in code, all you're describing is some instructions that could be performed later in the program if you ask them to be performed. So what we're about to write down here is kind of weird. It's different than what we've done so far. We're going to write some computer instructions, but they're not actually going to be performed yet. I'll show you. First, to create one of these functions, again, that's what we call the subprogram, you use the word function, like that. It's a special JavaScript word. And then you do a space, and you decide on a name for this function. What are we going to call it? I want to call it check, and you do I'm going to use underscore. It's like you do a shift and the, on the dash symbol. Check underscore hit. Hit is a lot easier to spell than intersect. So we're going to check whether or not we hit the food. I think that's a great name for a function. Check hit. Now, remember on our very first instruction, the alert one up here, how I talked about the fact that this instruction needs to be given information in order to do its job. Specifically, this instruction needs to be given, hey, what's the content you want me to display in this pop-up? Well, functions are like that too. When you're making a function, you need to clarify, does this function need to be given any information in order to do its job? And yeah, it absolutely does. It needs to be given whether or not the snake has hit the food. It needs to be given that information. So it needs to be given what we call a parameter. Now, parameters are fun. You get to decide, when I give information to this function that I'm creating, what do I call that information? I prefer to call it match. Oh, I don't type that out. I messed up. You put the information, the parameter, inside of parentheses. So give yourself a parentheses there. Go back inside it. And now, like I say, we get to decide on what we're going to call the information. We're going to give it whether or not there's a match between the position of the snake and the position of the food. We're going to call it match. So just type the name of what you want to call it. We get to call it whatever. And then right after that, hit enter. Do that same curly brace, hit enter a couple times, and the end curly brace. Now, what goes inside these braces is the instructions, and this is so critical. The instructions that will be performed only if we ask our function to be performed. These instructions you're about to write might not ever happen when you run your program. You're in control of whether or not they happen. And I'll show you how to make them happen in a minute. But just think about that. What we're putting inside these curly braces are instructions that are only going to happen if we ask the function to be performed later. But let's concentrate on, well, what are we going to do? Well, all we're going to do is check to see whether the parameter we got right here, match, is true. And if it is, well, we kind of know what we're going to do. We're going to print hit, snake gets bigger. And we'll put down what to do if it's false. And we're going to print miss, snake stays the same. You know, we've already done this, but we're putting those instructions inside this neat little package, a package called check hit. And now every time later on, you want to check whether or not the snake has hit the food, we don't have to type out this long series of instructions right here. We can just type out check hit. Let's see how we do that. So go back down, look where my cursor is. It's right here in between the curly braces. Hit spacebar twice just for readability. Makes it easier to read your code. And let's start figuring out this logic again. What we're going to do is we want to say if, in parentheses, match, which is this parameter we brought in, is equal to true. Hit enter again and give me those curly braces that we're getting used to. Go in between them and hit space a couple times for readability. What do we do? We're going to do an alert that says snake hit food, snake get bigger. I like having fun with some of this, like that. We're talking like Frankenstein today. Now, we've covered what to do if the parameter that we passed in, match, if it was true. Now we need to figure out what to do if it's false. So we hit enter again. Look where my cursor is. It's right here. I'll move this around. Here's my cursor right here. Hit enter and do that else instruction. Hit enter and give me those two curly braces again. Go in between them. Hit spacebar a couple times just for readability. And we'll do another alert that says, oh no, you missed snake, no, get bigger. I have no idea why I'm talking like Frankenstein. And do your end semicolon. Make sure you don't miss your double quotes on either side of the text. Don't miss your end parentheses, which says, hey, we're done giving the information to the alert instruction. And don't forget the semicolon, which tells JavaScript we've reached the end of this whole instruction. All right, now I'm going to leave that there for a moment. Look through and make sure you typed exactly what I said. Don't run your code, please. And now, I want you to look at this code and tell me, your guesses in chat, what is the final alert going to say when we run the code? What is the last alert that pops up going to say? Put your guesses in chat. Bingo, Debbie. That was spot on. I want to see some more guesses. Jim, I think you're right, but give me the exact text. You can probably even copy and paste it from the code where you think it's going to happen. Give me some guesses here. I'd love to see what you think is going to happen. Spencer, you're right. Scott, you're right. Okay, good. So let's run it. Yep, spot on, Spencer. So here's the first one, hello world. Here's the second one, has a snake intersected, true, because it was true right there. Here's the third one, has a snake intersected, false, because we changed the value to false. And the next one is missed, snake stays the same size. Oh yeah, that makes sense, because we checked whether this variable intersect was true. It wasn't. We had just changed it to false. And then we click OK, and that's it. There's no more. So Spencer had it exactly spot on. He said, this function that we made isn't being run. He's right. So how do we run the function? You have to call it. Go down to the bottom here, after the function. Look, everything I'm highlighting right here, that's your function. It's super important to think with, how does the computer handle it when it gets to this section of code? And what the computer does precisely is this. It reads this whole thing that I have highlighted. It goes, oh, we're creating a function. All right, well, what's its name? Okay, good. All right, does it take a parameter? Yeah, it does. It's called match. Okay, and it's storing all of this stuff in memory, right? In the memory devices in the computer. And it says, all right, what are the instructions inside this function? And it says, oh, here are the instructions. So it goes, all right, and it stores those instructions in memory. It doesn't do them. It just stores what it could do in the future. That's all that happens. That's what this whole chunk of code does. So now, sitting there in the computer memory is a whole set of instructions called check hit. To get them to run, go down to past this, you just type the name of the function, check_hit. And in parentheses, you pass in whether or not we hit the snake. Let's say it's false. We're going to do this every single time the snake moves. We're going to run check hit. Let's run this. There's our number 1. We expected that. There's our number 2. There's our number 3. What's going to happen now? This is the missed. Snake stays the same. We expected that. Now what's going to happen? Oh no, you missed, snake no get bigger. Why? Because we called the function and we passed in false. Let's say this happens another time. Just the next time the snake moves, let's run check hit. And let's say it still didn't hit it. Sorry, we still didn't hit the food. Run it again. There's number 1, number 2, number 3, 4th, 5th, 6th. Pay attention if it happened again. We missed the snake. All right. Now let's say we finally hit the snake. Check_hit, and we'll put true. And now run it. 1, 2, 3, boom. Oh no, you missed. Snake no get bigger. Do it again. Oh no, you missed. Snake no get bigger. Do it again. Hey, snake hit food. Snake get bigger. Here's the point I want to make. If we're going to do this logic every single time the snake moves, we've got to package all that up in some sort of a subprogram so that every time the snake moves, we're only writing one instruction. And we're passing in whether or not the snake hit the food. That's all. And that's the powerful value of a function. Let's say, for example, I had actually done this logic right here over and over and over again, like hundreds of times in my program for every single time the snake moved. Let's say I said the snake gets, 100 moves. That's a nightmare. And let's say I wanted to change what gets communicated. Well, now all I have to do is go inside my function and go, Erik, I don't think your stupid grammar was the smartest idea. Let's correct it. Let's go snake gets bigger. Let's say snake missed. And we'll say snake does not get bigger. Let's make it more polite. Erik was obnoxious. I only have to change that once. And now it gets reflected every single time I call check hit. I can run it. There's 1, 2, 3. And now here, we're hitting the function calls. Oh, that's more polite. That's better grammar. Snake missed. Snake does not get bigger. Do it again. Snake missed. Snake does not get bigger. Do it again. Snake hit food. Snake gets bigger. Okay, that's better. So I get to make my changes that I made right here be reflected in every single time I call the function. And again, I've used these really, really simple examples of just changing what we print to the screen. But bear in mind, you can have all kinds of complex instructions that are only done when something's true, and all kinds of complex instructions that only are done when something's false. And so it gives you fantastic control over your program's execution. And you can package all that up inside of a function and only do that when you want it to happen. So those are some of the building blocks of a computer program. All right, I'm paying attention to Q&A. Let me switch over here. What I want to do now is I want to give you all the full code. So let me drop this since I have it handy. I'm going to go into chat, and there is a link to the Google Doc that I'm looking at. Just go in here and first of all, copy all of the code. Copy all of it. And then go back over here to your editor and replace everything. Do a Control-A, erase everything, and then paste in the new code. After that, you should be able to play the game. You use the arrow keys. Everybody play for a minute just to get used to it. Have a little bit of fun. Sorry, I love playing this game. Okay, all right, that's enough. Okay, so let's go ahead and start talking about the code here on the left. We're not going to read through this entire program. I just want to point out a couple of things. Elena, did you erase everything on the left before you pasted it? And did you do a, over here, a Control A and then a Control C to copy every single bit of code? I'll try it again. Erase everything. Make sure you copy all over again and paste it in. It's not that important to get it to work on your particular browser, but it would be nice. You might have to switch browsers. All right, let's talk about this code a little bit. Now, again, all of this is HTML. We don't care about that. It's not JavaScript. This is still HTML until we get to script. Everything inside here is all JavaScript. And you can start to understand a little bit more what we're doing. It looks like we're making a variable called canvas, another variable called CTX, a variable called scale, a variable called rows and columns. There's another variable called snake. And look, we're making a function. Oh, okay. Now, yes, there's a lot in this program that you're not yet going to understand all of. That's why you study JavaScript in detail. But you can start to see some of the basic parts of what's going on here. There are variables. There are functions. There are control and branching statements. Look at the if. This is to check if the snake has eaten the fruit. Kind of cool. Okay. So you can check for collision. I called it a match or intersection. We're calling it a collision here. Okay. So you can start to follow along a little bit with the code. Now, if you've gone through one of our boot camps or learned JavaScript in detail, you can not only write this all yourself, but of course, understand every single bit of the instructions. The point is that this is not total gibberish if it was before. Some of it's understandable. And the only things in this program are entrance point, variables, control and branching statements, and subprograms. And of course, an exit point. Those 5 elements, that's all there is in here. And so it helps you start to study the language. All right. Elena, did you get it to work? Good. Awesome. Excellent. Thank you. Okay, good. Let's go back over here. Okay. Joshua said the sound cut out after I clicked the link. I've never had that happen before. I'm not sure what that is. All right. Q&A. Post any questions that I haven't yet gotten. Drop them in the chat. Let me see if there's any questions. We got a couple minutes here. Okay, cool. So let's go back over here. I want to have a bit more data about who and what we are and what we offer. I want to stress this might not be for you. Okay? It might be. I encourage you to stick around and find out. We've got a free gift coming your way in a minute. I think you'll like it. Okay, it's actually really, really helpful. And we worked on it for a long time. Just a bit more about what we do. We have 12 coding boot camps at the Tech Academy. And you can see they cover a huge range of technology subjects. Artificial intelligence. You might have been hearing a little bit about that recently, right? Computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. In fact, we have more certification programs than any other coding boot camp on the planet. But what's more important is how we run them. They are self-paced, but also instructor supported. They're flexible. You set your own study schedule and you can enroll any day of the year. The content on them is well-rounded and in-depth. They're affordable. Every single one of the programs includes both job placement training and job placement assistance. But most importantly, they're designed for absolute beginners. No technology knowledge or experience is required, so you don't have to be a nerd to get through these programs. I do drop a lot of really nerdy jokes in the curriculum, and I make no apologies for that. I am, in fact, a nerd. We consistently land on every major best coding bootcamp list because this industry is pretty mature at this point, and we've been around since the very beginning. Our average review rating across all of the major bootcamp review websites is 4.8 out of 5 stars. That's based on student and graduate feedback. We're really, really proud of that as well. And there's just a couple of questions about why you might even want to work in tech in the first place. I'm not assuming that everyone here wants to work in tech, but there are a few reasons I would suggest for why. It has great work-life balance. Remote work is actually very possible, especially post-COVID. It's a very creative industry and an industry where you can take a lot of personal pride in your work. It's a stable industry that pays really well. And if you keep applying yourself and learning more, there's regular increases in pay. Technologists are some of the best compensated professionals in the world. That said, there are barriers to doing a boot camp. There's barriers to everything. You can go in through, go to college, take you 4 years, cost you $150,000, $200,000. But you learn a lot of really cool stuff. You can do self-study. It doesn't cost you very much at all, practically nothing, but it takes a long time and you're not sure if you're studying all the right stuff. Or you can go through a boot camp. They're really effective for a lot of reasons, but yeah, they cost some money. It can cost thousands of dollars to go through a boot camp. Knowing that, we've tried to make this approachable to almost everybody. We have multiple financing options, including a large upfront payment discount, or different tuition options like different monthly payments for people with whatever financial situation they have going on. Another barrier to doing a boot camp, honestly, is time. There is a lot of material to cover. Some boot camps handle that by training people in what are called cohorts. One group of students that all start on the same day, and they all move through the curriculum at the same time. I could talk for hours about how much I don't like that model. We lose good people. Everybody learns at their own pace, is my experience, right? Some boot camps even make you attend in person. With the Tech Academy, all of our programs are online. They're flexible enough that you can choose your own study schedule because they're self-paced. So part-time schedule is allowed, which means you can study at the same time as you're holding down a job or going to some other school, like if you're going to college, okay? Which happens fairly often. Finally, in terms of barriers, there needs to be at least some technical interest or ability to get through a boot camp. But I want to stress one really important thing here. You may have felt at various points when you're trying to study coding or programming or computers, like maybe it's super complex and you're maybe not the brightest or it isn't for you. And I want to assure you, the problem is not you, it's the curriculum. Some education materials are too hard. And often they're harder than they need to be because educators assume knowledge on the part of the student. They assume you already know about a bunch of things because they've forgotten what it is like to be new. We've worked really hard to eliminate that. With our programs, you don't have to be a nerd. You don't have to have any technology background to enroll and to get through our programs. So I've got a question for you, a couple of them really. Are you working a dead-end job? One where the ceiling income-wise and job satisfaction-wise is not where you know you're going to want to get to? Or maybe you're even unemployed. Maybe you want to work from home. Maybe you want more time with your loved ones. The point is, and it's only a question you can answer, is it time for a career change? If it is, I'd like to put forth that the Tech Academy is the solution. We're career change experts. It's what we've been doing for over a decade. This bridge you see, the orange bridge in our logo, is there because we wanted to represent a route into technology for everyone. At this point, like I said, we've got over a decade of experience breaking people into technology. Most Tech Academy graduates make $30 an hour in their first job. That's $60,000 a year. We've got over 1,000 graduates working in tech. We need to update that because it's gone up significantly. And they work everywhere, anywhere from small businesses to the giants like Facebook or Nike or Disney or Uber or Epic Games. We have graduates at all those places and more, right? So as a reminder, we have open enrollment and you can start anytime. That expired. So, again, stick around for your free gift. We're about 1 minute from it. I encourage you to go to this link to find out more, okay? My assistant just dropped that into chat. When you fill out this simple form, what follows is a series of steps all about the Tech Academy. There's videos and articles, an optional step to book a call with our admissions personnel. We basically want to equip you with all of the information you would need to make an informed decision. So please fill out the form and then complete the steps after the event. I'll give you just a second to grab that link and fill out the form if you'd like. All right, I want to cover one thing real quick, which is that we do have a referral system, right? Since our graduates are really happy with us and have been for a long time, referrals have been a big source of enrollments for us over the years. And so years ago, we put in place a 5% commission payment for all referrals. Now, you don't have to be a graduate or student to do this. You can do it as well. In a moment, we're going to give you a way to email into us to get your free gift. If there are referrals you have, people you think we should be talking to, include their contact data. We'll get a hold of them. And if they enroll, we're going to cut you a check for 5% of their tuition. Period. End of story. We love doing it. We also have 7 publications that you might be interested in looking at, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a technology basics dictionary, a project management handbook, and a book called You Are Not Stupid, Computers and Technology Simplified, which is astoundingly valuable and represents, honestly, the culmination of about 40 years worth of work between myself and my co-founder. So we mentioned a free gift. Here it is. It's our Introduction to JavaScript book. This thing, we've sold thousands of these. It's very simple and clear and valuable. It's a great way to learn to program, okay? At least the introductions of it, right? It's like way beyond what we covered in this simple hour-and-a-half long course. If you'd like a physical copy of this, just email in asking for one, right? There's an email address that my assistant just dropped into chat, books@learncodinganywhere.com. Grab that email, throw us an email that says, hey, I was in the class with Eric. He said we could get a free Python book. Please send it. But make sure you include your mailing address. Every once in a while, someone doesn't include that. And you're like, we'd like to send it to you. Where? So grab that email. Also, if there's referrals that you want to send to us, put them in this email. I'll give you a second to grab that and fire off an email if you'd like. Again, just say, I'd like my free JavaScript book, please. All right, I mentioned our links. My assistant's going to drop this into chat. This is our link tree. It just aggregates all of our links for everything. Links to our YouTube playlist, our free educational videos, right? Links to our books, our dictionary, our upcoming meetups, if you want to come to future classes, our social media accounts. The links are all there. So please follow us on social media and come to our future classes. We'd love to have you, okay? So thank you for attending. Super appreciate it, right? Reminder, fill out that form at learncodinganywhere.com/Eric to learn more about our coding boot camps. I'd love to hear from you. Just find out whether or not it's for you, right? We've changed thousands of people's lives with our programs. Spencer, thank you. I don't hear that often. Spencer says, just so you know, I appreciate your jokes. I'm doing the software developer boot camp. So he's, yeah, I do drop some really nerdy jokes in the curriculum. I can't help it. I get talking about nerdy stuff and it just pops out. So anyway, thank you all so much for taking some time on a Friday night or a Saturday morning for those of you in the other side of the planet. I really appreciate it. Love to see you at future classes and have a great evening.